National Electrical Code Article 210.12 permits the use of multi-pole circuit breakers to protect multiple circuits, provided the circuit breaker's ampacity isn't exceeded. Section 210.12b further specifies that circuit breakers must be rated for the ampacity of the conductors they protect. When a single overcurrent protector device guards multiple conductors, it must be rated for the ampacity of the largest conductor it protects. Consider a 14-3 Hohmann cable, which includes two hot conductors typically black and red, a neutral conductor usually white, and a bare ground conductor, either green or bare copper. The neutral conductor is shared between both receptacle circuits. By utilizing a two-pole AFCI circuit breaker, both hot conductors and the shared neutral conductor are protected by a single device. This breaker will trip upon detecting an arc fault on either of the hot conductors or if a neutral connection issue arises. This setup aligns with the NEC and delivers the necessary protection for the receptacle circuits. The circuit breaker must be rated for the total ampacity of both receptacle circuits combined. The neutral conductor must be sized appropriately for the ampacity of the circuit breaker. The receptacle circuits must be connected to the correct terminals on the circuit breaker. In more detail, let's discuss AFCI circuit breakers. AFCI stands for Arc Fault Circuit Interrupter. These breakers are designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that can occur when insulation on wires becomes damaged or worn, or when connections become loose. These arcs generate heat, which can ignite nearby flammable materials, leading to a fire. Traditional circuit breakers protect against overloads and short circuits, but they don't detect arc faults. AFCI breakers, however, are specifically designed to detect the unique signatures of arc faults, such as erratic current fluctuations and high-frequency noise on the electrical circuit. When an AFCI breaker detects an arc fault, it quickly trips, cutting off the power to the circuit and preventing a fire. There are two main types of AFCI breakers. Firstly, branch or combination AFCI breakers which protect the entire branch circuit, including the wiring, outlets, and connected appliances. Secondly, outlet branch circuit AFCI breakers which are installed at the first outlet on the circuit and provide protection for the rest of the circuit downstream. The NEC requires AFCI protection in many areas of the home, including bedrooms, living rooms, dining rooms, and hallways. This requirement is intended to reduce the risk of electrical fires and improve overall safety. Now, let's consider the specifics of using a two-pole AFCI breaker for two receptacle circuits. A two-pole breaker is essentially two single-pole breakers combined into one unit. It has two hot terminals and is designed to protect two separate circuits that share a common neutral. In the scenario described with the 40-3 Hohmann cable, two hot conductors, one from each circuit, and a shared neutral conductor are present. When using a two-pole AFCI breaker, both hot conductors are connected to the breaker, and the neutral conductor is connected to the neutral busbar in the electrical panel. The two-pole AFCI breaker monitors both hot conductors for arc faults. If an arc fault is detected on either circuit, the breaker will trip, disconnecting both circuits simultaneously. This provides comprehensive protection for both circuits, ensuring that a fire is prevented regardless of which circuit the arc fault occurs on. The NEC allows this configuration as long as several conditions are met. Firstly, the circuit breaker must be rated for the total ampacity of both receptacle circuits combined. For example, if each circuit is rated for 15 amps, the two-pole breaker must be rated for at least 30 amps. Secondly, the neutral conductor must be sized appropriately for the ampacity of the circuit breaker. In this case, the neutral conductor must be able to handle the combined current of both circuits. Thirdly, the receptacle circuits must be connected to the correct terminals on the circuit breaker. It's crucial to follow the manufacturer's instructions when wiring the breaker to ensure that it functions properly. It's important to note that while this configuration is code compliant, it's essential to ensure that the wiring and connections are properly installed and maintained. Loose connections, damaged wiring, or overloaded circuits can all increase the risk of arc faults and electrical fires. Regularly inspecting the electrical system and addressing any issues promptly can help prevent these problems. Some additional points to consider are firstly, local codes and regulations may have additional requirements or restrictions regarding the use of two-pole AFCI breakers. It's always a good idea to check with the local electrical inspector to ensure compliance with all applicable codes. Secondly, when replacing an existing circuit breaker with an AFCI breaker, it's important to ensure that the existing wiring is in good condition and properly sized for the new breaker. If the wiring is old or damaged, it may need to be replaced to ensure safe and reliable operation. Thirdly, AFCI breakers can sometimes trip due to nuisance tripping, which occurs when the breaker trips for no apparent reason. This can be caused by various factors, such as electrical noise from appliances or faulty wiring. If nuisance tripping occurs frequently, it's important to investigate the cause and address any underlying issues. Another important aspect to consider is the proper grounding of the electrical system. Grounding provides a path for fault current to flow back to the electrical panel, which helps to trip the circuit breaker and prevent electrical shock. Ensure that all outlets and appliances are properly grounded and that the grounding system is properly installed and maintained. Now, let's discuss some potential issues that can arise when using a shared neutral circuit. Shared neutral circuits, also known as multi-wire branch circuits, can be complex to troubleshoot and require careful attention to detail. One common problem is voltage drop, which occurs when the voltage at the end of the circuit is lower than the voltage at the beginning of the circuit. This can be caused by long wire runs, undersized wiring, or excessive current draw. Voltage drop can cause appliances to malfunction or operate too efficiently, and it can also increase the risk of overheating and fire. To minimize voltage drop, use appropriately sized wiring and keep wire runs as short as possible. Another potential issue with shared neutral circuits is neutral overload. If the neutral conductor is not sized appropriately for the combined current of both circuits, it can become overloaded, leading to overheating and potential fire. To prevent neutral overload, ensure that the neutral conductor is sized to handle the maximum current that can flow through it. The NEC provides guidelines for sizing neutral conductors in multi-wire branch circuits. When working with electrical systems, it's always important to prioritize safety. To energize the circuit before working on it, and use appropriate personal protective equipment such as gloves and safety glasses. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Qualified electricians have the knowledge, skills, and experience to safely and effectively install and maintain electrical systems. They can also ensure that the work is done in compliance with all applicable codes and regulations. In summary, using a two-pole AFCI breaker for two receptacle circuits with a shared neutral is code compliant under the NEC, provided that the breaker is properly sized, the neutral conductor is appropriately sized, and the circuits are correctly connected. AFCI breakers provide important protection against arc faults and electrical fires, and they are required in many areas of the home. When working with electrical systems, always prioritize safety and consult with a qualified electrician if needed. Remember, electrical codes and regulations can vary depending on the location, so it's always a good idea to check with the local electrical inspector to ensure compliance with all applicable requirements. Understanding the principles behind AFCI protection and proper wiring techniques can help ensure the safety and reliability of electrical systems. Furthermore, consider the specific application and load requirements when selecting and installing AFCI breakers. For example, circuits that serve sensitive electronic equipment may require special considerations to prevent nuisance tripping. Additionally, certain types of appliances, such as those with motors or electronic components, can generate electrical noise that may interfere with AFCI operation. In these cases, it may be necessary to use specially designed AFCI breakers or to implement other measures to mitigate the noise. The NEC also addresses the installation and wiring of AFCI breakers in specific applications, such as branch circuits that supply electric vehicle charging equipment. These requirements are intended to ensure the safe and reliable operation of these circuits and to protect against potential hazards. In addition to AFCI protection, ground fault circuit interrupters, or GFCIs, are another important safety device used in electrical systems. GFCIs protect against electrical shock by detecting ground faults which occur when current leaks from a circuit to ground. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Understanding the differences between AFCIs and GFCIs and knowing when to use each type of device is essential for ensuring electrical safety. While AFCIs protect against arc faults and electrical fires, GFCIs protect against electrical shock. Both types of devices play an important role in protecting people and property from electrical hazards. Regular testing of AFCIs and GFCIs is also important to ensure that they are functioning properly. Test buttons are provided on these devices for this purpose, and it's recommended to test them monthly to verify their operation. If an AFCI or GFCI fails to trip when tested, it should be replaced immediately. Furthermore, consider the impact of energy efficiency on electrical system design and operation. Energy-efficient appliances and lighting can reduce energy consumption and lower electricity bills, but they can also affect the performance of electrical circuits. For example, LED lighting can draw significantly less current than traditional incandescent lighting, which could affect the voltage drop and neutral current in shared neutral circuits. When designing or modifying electrical systems, it's important to consider the energy efficiency of the components and to ensure that the wiring and protective devices are properly sized for the load. In addition to energy efficiency, sustainability is also an important consideration in electrical system design. Sustainable electrical systems are designed to minimize environmental impact and to conserve resources. This can include using renewable energy sources, such as solar power, and implementing energy-efficient practices throughout the electrical system. By incorporating sustainability principles into electrical system design, it's possible to create systems that are both safe and environmentally friendly. Regular maintenance and inspection of electrical systems are also essential for ensuring their safety and reliability. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems, such as loose connections, damaged wiring, or overloaded circuits. Addressing these issues promptly can help prevent electrical fires, electrical shock, and other hazards. Furthermore, consider the impact of electromagnetic interference, or EMI, on electrical systems. EMI can be caused by various sources, such as radio transmitters, electronic equipment, and power lines. EMI can interfere with the operation of sensitive electronic equipment and can also cause nuisance tripping of AFCI breakers. To mitigate EMI, shielding, filtering, and grounding techniques can be used. The NEC provides guidelines for minimizing EMI in electrical systems. In addition to the technical aspects of electrical systems, it's also important to consider the human factors. Electrical systems should be designed and installed in a way that is easy to use and maintain. Clear labeling of circuits and components can help prevent confusion and errors, and proper training of personnel can ensure that they are able to operate and maintain the system safely. Furthermore, consider the impact of aging infrastructure on electrical systems. Many electrical systems are aging and may not be able to meet the demands of modern technology. Upgrading aging electrical systems can improve their safety, reliability, and energy efficiency. This can include replacing old wiring, installing new protective devices, and upgrading the electrical panel. Finally, consider the importance of continuous learning and professional development in the electrical industry. Electrical technology is constantly evolving, and it's important for electricians and other electrical professionals to stay up to date on the latest codes, standards, and best practices. Participating in continuing education courses and attending industry conferences can help electrical professionals maintain their skills and knowledge and provide the best possible service to their clients.